Hey guys, and welcome back to a new video. In this video, I will show you how you can successfully migrate your room database in Android. So if you have some kind of database schema and that changes over time, then users who already have an app running with that old schema on their app, they of course need to kind of migrate to your new schema. And Room on its own usually doesn't know how to, just migrate the old schema to the new one. And that's what I will show you in this video, how you can tell Room what it should actually do. And I am in an empty Android Studio project here. I already added the Room dependencies. So on the one hand, Kotlin capped for annotation processing. And down here we have Room. So we have Room runtime, KTX. We have the compiler, testing. I will also show you testing here. So how you can test your migrations, which is actually quite important. And truth, which is an assertion library I like to use for testing. So in general, we will structure this, or I will structure this video in three major parts. On the one hand, I will show you Room auto migrations, so how you can automatically migrate your Room database that only works for specific things or specific changes. Then I will show you manual migrations, how you can pretty much migrate the rest that doesn't work with auto migrations. And in the third part, I will show you how you can actually test your migrations. And I want to start with just setting up a very simple table here for Room. And that will just be a user table. So we can create a new data class called user here in our root package, which will be a Room entity. And in here, we will just have something like an email, for example, which we can make the primary key. So that's unique. And we set auto generate to false. And let's also add a second field, for example, the username. We can then add a little bit of a DAO interface. So just an interface in which we define the functions we actually want to have to access our database, to retrieve users, to insert users, all that stuff. So we can make a user DAO interface, annotate that with DAO, and in here we want to have a suspend function to insert a user, like this. We annotate this with insert and set the onConflict strategy to onConflict strategy replace. So if we insert a new user with an email that already exists in our database, we will simply replace that existing user. And we want to have another suspend function called getUsers, which will just retrieve all of our users in our database. So we just get a list of users. Here we need to define a query. So we need to tell Room, hey, this is how you can actually retrieve all the users. We simply insert our SQL statement. We would simply want to select everything from our user table. And that's it for our DAO for now, at least. And the last step we need to do to actually set up our Room database before we can jump into migrations is we need a database class. So in our root package, we want to have our user database, make that an abstract class, and that will inherit from Room database like this. And here we can create our abstract val DAO, which is our user DAO, and the rest will be generated by Room. And we need to annotate this with database. So in here, we simply, on the one hand, define the entities, so all the tables we have in our database by simply having a little array. And we only have one type of table here, which is user. So we enter our user : class. And you can see we need to specify one more thing. And here it starts to get interesting when it comes to migrations. That is the version. And I'll start this off with 1. But what is this version actually now used for? The version tells Room, or SQL rather, if there was a change in our schema. So just to give you a quick demo, let's go to main activity and just create a simple instance of our Room database. We actually don't need compose here, since we just want to insert something into our database and read that, and we can simply print that as a log statement. So we can have our DB, we can create that using room.database builder, pass in our application context, our user database, and the name for our database as well, which I will say users.db. Then we can say .build. And then to just insert some users, some sample ones, we can launch a coroutine. Or actually, we can first of all say 1 to 10. So simply create a range to insert 10 users. And we say for each, we want to launch a coroutine in lifecycle scope. And we say db.dow.insertUser, and we create a user with some kind of test email, test, and we enter our current index.com. And also our username would be test $index, for example. So that way we just enter 10 sample users, and let's just read our users before that. Well, let's just launch our app once so we insert these users, and then we can actually read them and make sure to also print them in our console. So my app actually launched. You don't see the emulator here because you don't need to see it. We can now comment this out, and we can simply say, okay, lifecycle scope.launch, and we say db dow get users, and for each user we simply want to print them like this. And if we now of course launch this, then what we expect is that we see our 10 users that we actually inserted into our database, which is exactly what happens here. You can see our 10 users. That is working perfectly fine. So what is now up with that version I mentioned? Let's say we now go to our user table and we add a new field, for example, created. So we just want to add a timestamp when this user was created. If we now relaunch this and take a look here, then you will notice that our app actually crashes because Room cannot verify the data integrity. And it tells us, looks like you've changed the schema but forgot to update the version number. So that's exactly what we did. We changed the schema, we changed something in our table, and we did not update the version number. So we did not really tell Room, hey, there's actually a change in schema, and here's a migration that you should use to actually migrate the old schema to the new one. Because right now, if we take a look at our old schema and we search for user again, then this is the current data that is in the app from our current user base, but now we changed the schema. But how should Room actually now know what it should assign for this new field that we introduced, this created timestamp? Room can't know that, of course, so we need to kind of give it a rule that it knows what it should actually use for that field now when we migrate. And that's where we come to auto migrations in Room. That's actually something that was introduced not too long ago, I think with Room version 2.4.0 or so, which we currently use 2.4.3, so really not too long ago. Auto migrations basically, well, what the name already says, they allow us to automatically migrate our stuff. So we don't need to specify custom migration rules for Room, which is of course a lot easier. But that of course does not work for any type of schema change, only for a few. But for example, for the change we actually did, that we just added a field that ideally has some kind of default value, then that works. So let's go through this step by step, how we can now apply an auto migration to our Room database so it will properly fill out this created field with some kind of default value or whatever we specify. And the first thing I want to do is I want to go to build.gradle app, because in here under default config, we want to add this block of code. We need to specify some arguments for Room, which is a schema location. So what Room will now basically do is it will export our different schemas. So when we actually keep on developing our database, then Room will save JSON files, and each JSON file corresponds to one specific database version in which the current schema of that version is just saved. That's just very helpful if, for example, in future something breaks and you want to go back to a specific schema, then this JSON file will actually help you. You should put that in version control, just push it to your GitHub, and then you will just have references to the schemas of all your different versions. And that will just also be needed if we want to migrate or auto migrate our Room database. So we can click synchronize now and go back to, where do we go? User. Because what we now want to do here is we need to tell Room what is now the default value for that created field. Since that field, of course, did not exist in our old schema, we now need to tell it for migrating, what should it actually assign to that field by default. And what we want to do is want to add an annotation, add column info. And with that annotation, we can specify that. So first of all, we need to specify the name, which is simply created again. But then as a second argument, we can specify the default value. We actually need to specify that as a string here, but we deal with a long, so we can also just assign 0 here, for example. And we could also say that's equal to system current time millis. However, it will assign the 0 as the default value. So I don't think there's a way to make it use this one here as a default value. And you can also not use kind of dynamic values here as the default one. So in that case, if you want to update all your users to a specific created field, then you would either need to make that a manual migration, or you would need to simply run some code to actually update your whole database with the value you actually want. But this way, Room will just go through our database and just add this created field to all of our user entries and set the value to 0. That's not enough yet. We also need to go to our user database. First of all, increase the version, because we now changed our schema. We added the created field. And we want to add another parameter here for our annotation, which is auto migrations. And in here, we can specify a list of auto migrations. How do we do this? Well, we say auto migration. And here we now need to specify from which version we actually migrate to which. So what this corresponds to here for this auto migration. So from would be 1 and 2 would be 2. So we migrate from 1 to 2. And yeah, that's pretty much all we need to do, I think, at least. Let's now go here and launch this, and let's hope that this does not crash again. It does. Schema 1 JSON is required for migration, was not found. Okay, I see what the issue is. So this schema 1 JSON is now the file that Room actually generates when we have a schema and we launch that in our app. Since we just added the compiler arguments here for Room in our build.gradle app file, it doesn't know our first schema. So we probably just need to change the version back to 1. We can uncomment this, or we can, comment this for now. And we can also comment the new fields here for now. So that's just the state of our very first schema. And then if we switch to the project tab, actually, there should be, here we have a schemas folder. You see we already have a 2.json file, which is our second schema for version 2. You can see here is our created field. It's not null, it's an integer and all that stuff. So this JSON file just contains the current schema. But there is the file 1 missing because we added the compiler arguments later, and it needs these 2 JSON files to properly migrate. So we should be fine in actually running our app again now with our version 1. And hopefully it generates our schema 1 JSON. You can see here it is. This one does not contain the created field. And with these 2 files, it can now just guess the difference and properly migrate with that. So if we now simply uncomment this again, and we say that's version number 2, and in user, we actually also uncomment this, and we now relaunch this. Now that it has these 2 JSON files, take a look in logcat. And now you can see those were our users before migration with version 1. And now here, those are the users with version 2, where the created field is simply set to 0 for every single user. So let's actually take a look at what else we can do with auto migrations. Right now, we just added a field to a table, which is pretty simple. So then we just specify this auto migration here and we're good. But auto migrations can actually do a little bit more. For example, what happens if we want to rename a field in a table? Let's say we decide, hey, this created field should actually now be called created at. So we rename this. Yes, we say do refactor. And that is also a schema change, of course. But how does Room now know which field actually was renamed? Because this could also potentially be a new field. So for Room, it's not clear if we remove the old created field and introduce a new created at field, which might have a totally different purpose, or if we rename an existing field. So Room cannot know that, of course. So what we need to do is we need to tell Room, hey, we actually changed the name of that field. And for that, we want to go to user database. We want to migrate this to version 3 now. And we want to specify another auto migration. We can simply duplicate this. This one we migrate from 2 to 3. And this time, we also need to define such a spec, so an auto migration spec. And we typically do this here in this user database class, where basically the database we want to migrate. Here we can define a class. I will call this migration 2 to 3. And this will be an auto migration spec. And that's all you need to do. So not all you need to do, but I mean, you don't need to actually implement this class, but you need to add an annotation to this. And that annotation will be rename column, because that's what we did. We renamed a column in one of our tables. And that way we actually tell Room, hey, Our table name that actually changed was user. Our from column name, so basically from what we renamed to something else, was created. And to column name is created at. And now we can take this migration to the 3 class and specify it here as a spec. So migration to the 3 double colon class. That should be it. Let's relaunch our app, take a look in Logcat. And now you can see, first we had our created fields, and now we have all of our users with created at fields. So that is also working perfectly fine. If we take a look in our file system, we now also have a 3.json file, which contains our new schema with our new created at field. So that is how auto migrations work. You will also need these annotations if, for example, you deleted a column. So then you will need the delete column annotation. If you deleted a table, you need this. Or if you renamed a table, rename table, then you can also do this with auto migrations. But for the rest, what you can do with these annotations, or if you just added a column, for the rest you actually need manual migrations. So you will need to enter SQL statements that tell Room and your database which things actually change in which way. So for example, for more complex changes, if some relations in your database changed or so, or if you added a whole new table to your database and that might have some relations or not, then auto migrations can't do that. And in that case, you will need manual migrations. Luckily, you're here on my channel, so I will also show you that next. Let's actually go to our root package, and I will go back to the Android view here. And in here, we will create a new class, which I will call school. So just a new entity for our database. Let's just say we save some schools and we annotate this with @entity. And I'll just make the primary key simply the name of the school. And let's also set auto generate to actually false, like this. So now we added a new entity to our database. We also need to add this here in our list. So here we say school, double colon class. And now if we would actually relaunch our app, it would crash again since we changed our schema, but we did not change our version. And if we would change our version and just add an auto migration, then this would also not work because auto migrations don't work if we want to add a new table. So what do we do now? Well, let's actually first of all go to our DAO, add some kind of function here to insert a school, insert school, make that an insert statement or insert annotation. On conflict strategy, as usual, we set to replace, and we want to have a function to actually get our schools. Suspend function get schools, list of school, and the query we run is select all schools, like this. So now what we need to do for this manual migration is we need to go to main activity. Usually, of course, in a normal project, I would not put all this stuff in main activity. This is just for demo, but we can then actually let's actually go to our user database and declare our migrations here instead, just like our auto migrations. And in here, we can say val migration. This one will be 3 to 4. And here we need to create that using an anonymous class, which is equal to a normal migration now. And here we also need to specify the start version and the end version. So this one is from 3 to 4. And in here, we can actually implement the migrate function. So this is now called as soon as a room wants to migrate from version 3 to 4. And this time we get a database reference. With this database reference, we can run raw SQL code. So we can say database dot execute SQL, and here we can simply put in an SQL string that will be executed on migration. And what we can do with this is we can create our table that Room actually expects to find to be able to insert schools using our DAO then. And how do we insert a new table? We can say, actually not select, we can say create table if not exists. The name of the table is school. And in here we define the different columns we have for that table. We simply have a name column just for simplicity here. So that is name. We say that's a character. So I mean a string that is not null. And that is our primary key. That is how we tell room how our table actually looks like. And of course, if we want to do more complex migrations, then you need to know SQL. I think that should be clear here, and that is beyond the scope of this video to teach you whole SQL. For example, if you want to split up a table or so, if you want to, have very complex or specific migrations, then you can do this with Room, of course, using this strategy with this migration class. But that's, of course, a little bit complex, especially if you don't know SQL. So that is our migration. That is just that the table exists when we then run our app. And yeah, that's of course a condition that needs to be true if we want to insert something in that table. We want to bump up our version to 4, and we want to go to main activity. And if we have these manual migrations, we actually need to also add these to our database builder. So here before build, we want to say add migrations. And in here we put in all of our migrations, all of our manual migrations that we have for our room database. So this one would be user database.migration 3 to 4. And why doesn't it recognize that? Unresolved reference. Of course, because it's not in a companion object. So let's go here and put that in a companion object. Like this. And then, yeah, now we are actually good. Let's get rid of our users now because we don't need these anymore. Or let's simply switch this to get schools. And let's uncomment this. And here we say insert school instead. Create a school object. And the name is simply this. So now, since our current the last APK still uses the schema without schools, and now our new schema uses schools, we should be able to not see any print line statements because we insert the schools afterwards, but we should at least not get a crash. So if we now run our app, take a look in logcat and search for, well, let's just keep the general one. There are no crashes, that's good. If we search for school, nothing in there. That is normal. Let's actually comment this so we don't insert them again. Relaunch this, and now we should actually be able to see some schools. And yes, here are our schools. So we successfully also added a new table to our room database with a manual migration that worked perfectly fine. Also, if we take a look in our schemas folder, here's our schema 4, which contains our new school table as well. So that worked perfectly fine. And now if you do this in a real life project, then it can of course easily happen that you have some kind of mistake in your migration. And that is not so cool because if a migration breaks, that breaks your whole app because you just saw how easily Room can make your app crash. So what do we want to do? We want to test our migrations with normal automated Android test cases. Those will need to be instrumented tests, so that means they need to run on an emulator because creating a room database requires the context, and that only works with instrumented tests. But I will show you how you can do that to actually check if your migration was successful or if it actually migrates what it should migrate. And the first thing we want to do is we want to go to our bullet grill app file again, and we want to add one more block of code here below our default config block, which is this one. So we define source sets, and here we simply say, okay, for our Android test source set, which is the directory in which we put our instrumented unit tests, or just instrumented tests, here we want to simply add our schemas directory to this source set so that this source set can access our database schemas, because that's what's needed to actually test our migrations. We hit synchronize now, and I will switch back to Android. And now we want to go to Android test, where we put our Android tests, well, our instrumented tests. And in here we will put our migration test, or let's say user migration test. Simply a class. We define our test runner here above with run with, and that is the Android JUnit 4 runner. We want to have a private const val for our database name. TestDB, for example, or just test, doesn't matter here. And then in here, we want to actually test our migrations. So there are actually two things we could test here. On the one hand, we could test a specific migration. So for example, from version 1 to 2, that works. Or if we say we simply want to run all of our migrations and just check if there are any issues, if our app crashes in any of these, we can also write a single test case for that. And I will of course show you both of that. And the first thing I want to do is we'll have a JUnit rule. So these rules simply add new behavior to our test cases, and we can also use these to just get access to special functionality. In this case, in regards to room, for example. And this room, this room rule will be called helper. And it is a so-called migration test helper. And here we actually need to pass quite some arguments. First of all, the instrumentation, we can get that with instrumentation registry dot get instrumentation. We need to specify the database class, just as we also needed to do for our room builder, which is user database class Java. We need specs. So those are now only our auto migration specs, so that we can also test these, of course. That will be a list of our migrations, actually. Actually, not all of our auto migrations, but it means these custom ones we defined here, but not all of these here. So going back, we simply say migration 2 to 3. That is our auto migration spec. And it seems like it has some issues. Let's get rid of that package name, maybe. Yeah, then it works. And an open factory, which is simply a framework SQLite open helper factory. And then we don't get any more issues here. We have our rule, that's cool. And we can now start to write our test case. And we do this by simply annotating our function with add test. And we call this migration 1 to 2 contains correct data, for example. So just making it clear what we test here, we test the migration from version 1 to 2, and we want to verify that after migration, it contains the correct data. And testing migrations is also very SQL heavy, so we don't have an auto migrations test that we just say, hey, test all of our migrations and verify the behavior without us needing to write any code. That's sadly not so easy. We first of all actually need to get a reference to our DB. That actually needs to be a var. You will see why, var db, and that is equal to helper.createDatabase. Our name is our DB name, and the version you want to create is version 1. And then we can say apply, because the thing is, if we actually create our database with a version that is not the latest one, then DAOs don't work, because DAOs only work for our latest database version. But since we want to test the migration, we actually need to create our database kind of manually here to get a reference to a support SQLite database, and we can then use it to run some queries, to insert data, and to just make some checks or so. So for example, we can say execute SQL, and in here we now want to insert a user. So we insert into user. We want to insert the values. First of all, well, if we take a look in our schema, you can see now why that's helpful. Our schema 1, because that's the database we currently create. Here we have fields, email and username. So we now need to enter a user with these two fields. So first of all, email, test@test.com, for example. And the second one is the username, for example, Philip. Then we can close our DB. So we now just have one entry in our table that we want to test if the migration was successful. And the way we do this is we now set DB to helper, run migrations and validate. The name is our DB name again. The version is now 2, so we want to migrate to 2. I want to set validate drop tables to true. And now what do we actually want to verify? Well, if we take a look at our first migration, then here's our schema 1 and here's our schema 2. So what basically changed is that we added this created field, and the default value is 0. So we want to check that if we have our table, our users table in our schema 1, and we migrate that to schema 2, that all of our users contain our created field with the default value being equal to 0. That is what we want to now verify. So now we can go here and we can say db.query. That's what we use to actually get a list of users. We want to get everything from our users table. And then we can say .apply. And here we get access to a so-called cursor that's used to actually kind of loop through the result, all the results that we get from this query, and actually get access to the single columns. So first of all, I want to say assert that comes from truth. Can I import that from truth? I want to assert that move to first is true. So move to first is used by this cursor, and we basically move to the first entry, and it returns true if there is a first entry. So we, of course, first of all want to assert that there is an entry after migration. That is the first thing we want to make sure. And the second thing is that the created field of that entry actually exists and is equal to 0. So we assert that get long, because that field we want to get is a long. And here we need to pass an int, which is the column index. We can get that using get column index. of a string, and the string is simply the name of the field, so create it. And then we want to make sure that this is equal to 0, because that's what we expect should happen after migration. And if we now run this, we hopefully see a passing test. You can see it is compiling. And you can see the test case actually succeeded, which is exactly what we expect. Cool, so that migration test worked. So now you know how you can test the migration from one version to another one. But as I said, I will also show you how you can test all migrations one after another in another test. And that's also not super difficult. That's actually even a little bit easier than the one we wrote. Want to have another test? Function test all migrations. And here we say helper.createDatabase again with our DB name, version 1, since we now want to migrate from version 1 to 2 to 3 to 4. And we say apply close. So we simply directly close our DB. We just want to create it. We don't want to insert anything, because all we now want to test is that nothing crashes in the end. So yeah, no migration will actually crash on the user side, which is of course what we want to avoid. And we can then say room database builder. For the context, we can say instrumentation registry, get instrumentation.target context. Class is user database, ;class at Java. The name is DB name again. And here we again say add migrations just as we did in the main activity. And we need to add our migrations that are not automatic. So no auto migrations, just the manual ones, which is user database migration 3 to 4. And we can then say build, apply, and we also want to close this DB, so we can say open helper writable database, that's the instance, and we call close on that. And if we now run this test case, we should hopefully also see a passing test. Taking a look at the results tab here, and you can see here's our passing test. So there are no crashes or so, because if it would crash, then the test case would also obviously fail. So if there's any exception, that is thrown by Room. So I hope this rather long video actually gave you a good overview of Room migrations, and you're actually now confident enough to also apply these in your own projects. If so, I would be very happy to hear about that in the comments. Also, if you have any specific wishes or ideas for future videos, I'm always happy to hear these, so I get some inspiration, and maybe I'll also make a video about these then. If you haven't subscribed to this channel yet and you like this video and you want to see future videos that are similar like this one, then now is a very good chance to actually do that. It's free, and maybe we'll even reach the 100,000 subscribers at the end of this year. That would be amazing, and yeah, would be a great way if you actually want to give a little bit back for all these free videos. Thanks so much for the support, and I will see you back in the next video. Have an amazing week. Bye bye.